All right, here are solutions for quiz 8 for Math 211. In this problem, you are given, or in this quiz, the first problem, you're given this number 55,440 and asked if it's divisible by the following numbers using our divisibility trick. So don't use long division or something or a calculator. Determine if it's divisible by 4. Yes, it is divisible by 4. How do I know that? Yes, because the last two digits form the number 40. And 40 is divisible by 4. 10 times 4 equals 40. What about divisible by 11? Well, to check divisibility by 11, I take every other digit. So I'll take this first 5, and then this third digit, the 4, and then the fifth digit, the 0, and that gives me 9. And then I'll take this second 5, and then this fourth digit, which is a 4, and that gives me 9. And 9 minus 9 equals 0. And so I'm going to say yes here. 0 is divisible by 11. Or maybe put differently, 0 is a multiple of 11. So therefore, this entire number is divisible by 11. What about divisible by 36? It'll turn out that that answer is yes as well. And the reason that's yes, let's see, needs to pass the 4 and the 9 tests. Note that those guys are relatively prime. It's important. So I need two tests where the product of those numbers is equal to 36, and those numbers are relatively prime. So I couldn't check the 6 test twice, or the 2 and, I don't know, 18 or something. But I could test the 4 and the 9 test. It already passed the 4 test. To check the 9 test, I sum up all the digits, 5 plus 5 plus 4 plus 4 plus 0, and I get 18. So it passes the 9 test. 18 is divisible by 9. So this number is as well, and since it's divisible by 4 and 9, it's divisible by 36. Use the results of question 1 to find the prime factorization of this huge number. Okay, so I have this big number, 55,440, and I need to create a factor tree, but it'll help to know that it's divisible by these numbers. So one way I could do this is I could say 5544 and 10. Like, oh, we're going to get into trouble. I don't know what numbers divide evenly into 5544. Well, you kind of do, because 11 has to divide evenly into this number. It'll turn out that 11 times 504 gives you this value. And then 504, I could take that one further. See, it's even. So I have 252 times 2. I guess it was divisible by 4. Could have taken out another 2 here. That leaves me with 126. I keep going with 126. That's even. And it leaves me with 63. And 63 is 9 times 7. And 9 is 3 times 3. So what I get for the prime factorization is, let's count up my 2's. I got a 2, another 2, that's 2 of them. There's a third one. There's a fourth one. So I have 2 to the 4th power times, what do I got in terms of 3's? Got 2 3's right here. So I got 3 squared. Do I have any 5's? Yup, 1 5 right here. What about 7's? Oh, I didn't circle that. Yeah, I got a 7 right here. And then I got an 11 over here. And don't worry about the fact that the 504 and the 126 aren't circled, because the 504 kind of jumped up here just because I ran out of room. Here's my prime factorization. Determine how many positive whole numbers divide evenly into this number. Well, as we learned in class, there's an easy trick for doing this. All you got to do is look at the prime factorization and add 1 to each of the exponents. So if I add 1 to 4, I get a 5. If I add 1 to 2, I get a 3. If I add 1 to the 1 that is the exponent of these next 3 numbers, I get 2. And if I multiply these guys all together, let's see, that gives me 10, and this gives me 12. So I'd end up with the number 120. So what that means, there's our 120 positive whole number factors of this huge number, 55,440. Find the greatest common factor of these guys. Well, to find greatest common factors, I also need prime factorizations. I already have the prime factorization of this number, so let's find the prime factorization of 704. Ooh, that's a strange looking 704. Well, let's see. I know 704 is an, well, I could do this a couple of ways. I know it's even. That's probably the easiest way. So it's 2 times something. That something ends up being 352. I know that 2 is even. So 352 is 2 times something. 176, I believe. Yeah, 176 is still even, so that's 2 times something. Let's see, 80 times 2 is 160. I need 16 more. This would be 88. And here, a nice thing happens. 88 is 8 times 11. And 8, I guess I could write as 2 times 2 times 2. So what I have for the prime factorization of 704 is a whole bunch of 2's and an 11. How many 2's do I got? Well, let's see. 1, 2, 3, 4, 5, 6. I got 2 to the 6th power times 11. So now if I want to figure out the greatest common factor of these two numbers, what I have to do is look at their prime factorizations. So I have that written here and here. And take each of the different prime numbers and write the smaller of the exponents. So I have a 2 here and a 2 here. The smaller of the exponents is a 4. I have a 3 here, but no 3's down here, so the smaller of the exponents is a 0. There doesn't get any 3's. No 5's down here, no 7's down here, but I have an 11 in both of them. So my greatest common factor is 2 to the 4th times 11. Let's see, 2 to the 4th times 11 is 176, I think, because 2 to the 4th is 16, and 16 times 11 is 176. So the greatest common factor is 176. I could find their least common multiple very similarly. Same idea, I'm going to look at the two prime factorizations, but now instead of taking the smaller exponent, I'm going to take the larger exponent. So I have 2 to the 4th power and 2 to the 6th power. The larger of those exponents is 2 to the 6th power. I have 3 to the 2nd power and 3 to the 0 power. The largest of those is 3 to the 2nd power. 5 to the 1st, no 5's there, so the larger is 5 to the 1st. Same idea with 7 to the 1st, and 11 to the 1st I have here and here, so the larger is 11 to the 1st. And if I multiply together all those numbers, which I cannot do in my head, but I could do with the calculator. If you want to watch me punch numbers into a calculator, you feel free. I have 2 to the 6th power is 64 times 3 squared. Well, 3 squared is 9. And times 5 times 7 times 11. And I get this huge number, 221,760. And so what that represents is the least common multiple of these two numbers. And that's the last question on the quiz, so I suppose I could end these video solutions here.